Alright guys, so it says, what is the domain for the following function? So I want you guys to think about this. What's going to restrict your domain? So you have to consider your vertical asymptotes and the x value for your hole. Okay? And I'll show you this kind of through your graph, because with the range, there's other factors that could affect your range that would make it where you don't necessarily always exclude your horizontal asymptote. You have to actually look at the shape of your graph. So to determine vertical asymptotes and the x value of your hole, we need to go ahead and factor each piece. Okay? So we would have this going on here. Now, I see that these x plus 1's cancel. So I know that I have a hole with an x value of -1. So the actual hole would be at -1 some y value. Okay, which the y value is not important here. We're just looking at our domain restrictions. So here we have a vertical asymptote of x equals 3. Now think about this. Y is 3 and -1. Why are those values going to be excluded from our domain? Because both of those values give us 0 in the denominator. Okay? So our domain, and we're going to look at the graph where you can see that, is from -infinity. What's the first x value we skip over? -1. Union, we are skipping that x value, but we're picking up right after that x value. So -1, oops, to 3, sorry, union 3 to infinity. Some of you may have seen it written this way as well. All real numbers except x equals -1 and 3. So let's just look at the graph for a second. Okay, so let me clear this graph out. Let's type the original one in. Make sure you put the entire numerator in parentheses. So we have x squared plus x divided by x squared minus 2x minus 3. I'm going to close that parentheses. I'm going to do zoom, standard. Okay, so with our x's, hopefully you guys can see that we are approaching. Let me see if I can draw it on the calculator here. Whoops. We are coming closer and closer to this x value here, but we never actually reach an x value of 3. Okay, and then we could look at the table if you'd like. We see an error at 3. Let's go this way, and there's also an error at -1, so do this as well. What if I pull the graph up and I do second calculate option 1 value, and I ask it what happens when x is -1? It doesn't give me a y value because it skips over that point in the graph. Okay? Alright, so let's keep going. So number 9, we don't need our calculator for this, so don't waste your time. What are the vertical asymptotes? Alright, so we are looking with our vertical asymptotes in the denominator, but we're looking at the factors that cancel, or that don't cancel, I'm sorry, that are left after we cancel. So check this out. I factored both of these. This x minus 3 cancels. What's left? X equals -2. You do not include the factor that cancels. So my only vertical asymptote is x equals -2. Okay? Alright, number 10 says fill in the key features. So first we're going to look at a graph. So let me kind of zoom this out for us so we can see the graph and the question. So vertical asymptotes, the graph is nice because they draw them for you. They're dashed. If they didn't draw them for you guys, you could kind of draw a line in between those two pieces of the graph that they don't touch and kind of estimate where it is. And you'll see it's at x equals -5. The horizontal one is here at y equals 1. You've got to include, hopefully you learned this from your quiz, the x equals and the y equals, or we can't count that as correct. Okay? I don't see any open dots here that we skip over, so I'm going to say there is no hole. Now looking at a table is a little bit trickier, the vertical asymptote and the holes are not too bad because those values are going to show up as undefined. So let's talk about what happens at this first undefined value. How do you determine the difference between an asymptote or the x value of a hole? Look at what's happening in your y value. So on the left side, as you approach that asymptote, your y values are increasing, okay? On that left side, as you approach the asymptote, your y values are decreasing. And notice that they're decreasing towards a different number. On the right side, they're going up to a positive value. On the left side, they're decreasing and they're going down. So we can assume they're going to continue going down and they're going to continue going up. Okay, so we have a big jump going towards 5 and increasing, and then going to -3 and continuing to decrease. So we can say that x equals -5 is a vertical asymptote. You can sketch the graph if you want and see how that helps. So I can draw a little bit of a sketch, ooh, goodness, for you over here. A little bit of space that I have. So let's think. As x, when we're at -7, 1, 2, 3, 4, 5, 6, 7. At -7, the y value is +3. Okay, I know that's kind of hard to see, so just bear with me. -6, our y value's at +5. Okay, and then we've got some undefined value here at 5. -5. So let's look at the right side then. So at -4, our y value is at -3. So do you see how there's no way our graph is going to continue and jump way down here to this blue point? So we can assume that this side is continuing to go up. And then over here, this side is coming from over here and it's continuing to go down. Okay? Now, for the hole, let's go ahead and talk about the hole real quick. So for the hole, we can definitely see the x value, but we have to sort of estimate the y value. So let's look at our other undefined pieces. We have an undefined piece here when x is 5. Okay? Now look at what's happening on either side of that. Can you see that we are increasing? We're increasing up to this point, and then we come on the other side and they're kind of decreasing towards this point, but they're coming towards the same value. Do you see how close those values are? So it's almost like they just skip over some numbers there. So that's what gives us a hole, because they're both kind of coming towards the same y value. They're not one going up towards positive infinity and one going down towards negative infinity. They're coming towards the same thing. So how can we estimate what the value might be between 0.55 and 0.63? So maybe we could say about 0.6, okay? A complete estimate, but the important thing is to know that you have a hole with an x value of 5, okay? Now, a horizontal asymptote is a y value that your graph approaches. So is there a y value that your graph's approaching as the x's increase? So I want you guys to notice what's happening here. Between all of these y values, as x is increasing, these y values increase very slowly. Okay? Can we assume that they're increasing to some number? Yes. What's a good estimate? Maybe they're increasing towards y equals 1. It would be helpful if we had more tables so that we could verify that, or maybe some tables in the far negative values. We could see that that side's also going towards the same value, but that's just a general picture of what the horizontal asymptote looks like on a table. Select the statements that are true using the information above, considering that the first function is f of x, while the second is g of x. F of x has a vertical asymptote at x equals -5, while g of x has a vertical asymptote at x equals 5. That's not true, because this is actually the x value for the hole. Okay? They both have a horizontal asymptote at y equals 1. That is true. All right? So let's keep going. Let's start looking at some of these applications. So I'm going to zoom this back in for us. This first one here. A boat travels at a constant speed of 3 miles per hour in still water. Actually, you know what? Let's save the applications for another video.